Okay, so yesterday we discussed about um, normal distribution. We saw the properties of normal distribution and also some of practical applications of what? Of normal distribution. Okay. As well, we discussed and defined that is skewness and kurtosis. We saw what really kurtosis is, what skewness is. Okay, and then after that we introduced another topic which was called central limit theorem. Okay, and we stated that is what the like the theorem. Okay, so for today I want us now to start with our binomial distribution. So for a binomial distribution, of course, it has some properties. Like we know that each trio has same probability of success and fail, and again, occurrence of one that is trio, okay, does not affect the occurrence of the second trio. Like they are mutually exclusive or they are independent, okay, to each other. Like each trio, its in outcome, it's independent, okay, but does not, and again it does not influence, okay, the outcome of the second trial. Okay, we shall see those properties as well, and then after that we'll discuss about some examples, okay, of binomial distribution. If I can remember, during our introduction I said that for binomial distribution we only have two possible outcomes. Okay, we have two possible outcomes. Either it's maybe like when we toss a coin, it's either we get a head or a tail. Okay, yes, so or maybe if we are in organization, we can categorize maybe in terms of gender, if maybe you are male or female. Okay, then also in survey questions we have yes or no. Like we only have two possible outcomes. If it's not a yes, it is what? It is a no. All right. Good. Then we shall do some, that is the properties. And then after that, we'll go now to the mathematical representation or probability mass function for the binomial distribution. And then we'll even explain further. Okay. And maybe to give you an that is heads up, is that in that is binomial distribution. Under binomial distribution, we can now get what we call binary trio. Like binary, that is binary distribution. It's a special that is binomial distribution. Okay. Then we'll check on our takeaways. Then get into okay, sorry, those are the octa things. Then we'll go to Poisson and see maybe what Poisson basically is. Okay, all right. I don't want to take much in explaining, because I know I will have time to explain everything during the when we are analyzing the binomial distribution. Okay. Otherwise, first of all, we can go through the introduction of the distribution and also see some of examples of the distributions or which kind of data might follow such distribution. Okay, and maybe some that is some properties of the distribution. Okay, so basically binomial distribution, we said it's a discrete distribution, meaning we don't have we are dealing with only discrete va values. Like for example, when we are talking about trio, we are talking about one trio, two trios, three trios, but not 2.5 trios. Okay. Yes. If maybe we are talking about success, it's either a success or a fail. Okay. All right. Then let's now define the distribution. So the binomial distribution is a probability distribution that summarizes the likelihood that a value will take one of the two values under a given set of parameters or under given assumptions. Okay, so we are saying that for binomial distribution basically shows us the likelihood of one of two events happening. Okay, meaning here we only have two outcomes. Okay, if maybe we are tossing a coin, it's either we get a head or a tail. There is no way maybe we can get the two outcomes at the same time. Okay, so basically we only have two outcomes. We don't have any third outcome. Okay, so it is either a head or a tail when you toss a coin. Okay, good. Then we are saying we that is under a set of assumptions. Okay, so we usually have some assumptions for binomial distribution to happen. Okay, so we usually assume that all the underlying assumption of binomial distribution are that there is only one outcome for each trial. Okay, we only have one outcome of each trial. So like for example, if we toss a coin, we can only expect one outcome, a head, okay, or a tail. Basically what I mean, of course, as per your expectations, as per your expectations, as per your expectation, you will need to do what you like, you might get two observations, either a tail or a head. Okay, so in this case our end outcome, we expect one outcome. Okay, so we are saying that there is only one outcome for each trial, that each trial has the same probability of success. Each trial has the same probability of success. So definitely, when we toss a coin, we know we can get a head or a tail. So when it comes to probability, definitely you are expecting what? It's like you are 50-50. You can get a head or you can get a tail. Okay, that's why we are saying we have the same probability. It's a 50-50 chance. Okay, so that was the second, that was the second assumption. Then the third assumption is that each trial is mutually exclusive, or each trial is independent of one another. Each trial is independent of one another. Okay, so like the outcome, or that is the outcome. Okay, or one out that is the outcome of one trial does not affect the what, the outcome of the other that is a trial. Okay, all right, good, let's continue. All right, now let's go to the second slide, that is in probability theory and statistics. Okay, the binomial distribution is a discrete probability distribution that gives only two possible results in an experiment. Of course, we had discussed this. Okay, then we are saying that, for example, if we toss a coin, Okay, if we toss a coin, there could be only two possible outcomes, either head or tail. If any test is taken, then there would be only two results. That is, like when we do an exam, we always have two that is results. Either you've passed or you failed. Okay, so this distribution is called a binomial probability distribution. That is the distribution which only has that is only one outcome at the end. Okay, even if we expect two possible outcomes, but at the end we'll only get what? One outcome. Okay, so binomial distribution examples, like as we already know, binomial distribution gives the possibility of a different set of outcomes. In the real life, the concept is used for maybe finding the quantity, that is the quantity of raw and used materials while making what? A product. Okay. Then also when taking a survey of positive and negative reviews from the public for any specific product or place. So it's like it's either a positive feedback or a positive review or a negative review. Okay. Maybe also by using yes or no in surveys, we can check whether the number of person views the particular what channel. Like for example, if I can ask you, that is if you have a Twitter account, okay? If I ask you if you have a Twitter account, definitely I will expect what? I will expect two possible outcomes, okay? Either yes or no. All right? Yes. Then to find the number of males and females employees in an organization. So with that, you can also do a survey in your organization to get maybe the data of female employees and male employees. Okay, so you will expect one of these two possible outcomes. Okay, then the number of votes collected by candidate in election is counted based on 0 or 1 probability. Like it's a win or it's a what? It's a lose. It's a loss. All right, let's now go to the probabilities of binomial distribution. So there are two possible outcomes in this case. It's either true or false, success or failure, yes or no. Only two possible outcomes. Okay, so we are saying that also we have there is n number of independent trials or a fixed number of any times repeated trials. So in this case, we know that n is what? N is always the number of trials. Okay, so maybe let me just illustrate that. So in binomial we usually have n, okay, and we usually have x. Okay, so n is the total number of trials. Okay, then x is the total number of successful 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 trials. Okay, trials. Okay, then this is the total number of what? Trials. Total trials. Okay, so like for example, if we are working with the example I had illustrated of basketball, okay, of basketball, maybe you are throwing the ball to get into or through the basket, okay, and then you are told do what? Do 10 trials. So 10 trials, it's like 10 rows, okay, to see if maybe that is how many times you will what you will that is your ball will go through the basket. Okay, so n is the total number of trials. Let's assume out of 10 trials, 8 of your trials, that is the ball made it through the what? The basket. Okay. So in that case, x will be what? Will be 8. Meaning we had 10 total number of trials, and then x, that is 8 trials were what? Were successful. All right. Yes, meaning now the number of trials not successful will be x minus what? N minus x. You'll get the number of fails. Okay? Yes. All right. Then the probability of success or failure remains the same for each trial. Of course, when you throw that is a coin, or you when you toss a coin, you know that maybe you are expecting a head or a tail. So your probability is 50-50, and 50-50 it's the same. Okay, it's the same probability. Like you have this same probability of failure and also same probability of what? Of success. Okay. Then the only number of success is calculated out of independent trials. So the number of successes, that is x, is calculated out of the total number of what? Trials. Then the last property is that every trial is independent trial, which means the outcome of one trial does not affect the outcome of what? Of another trial. So the outcome of first trial does not affect the outcome of the what? Of the second trial. Good. Are we together up to that point? If we are together by show of hand, Collins, we are together. Susan, Steve, Deborah, Rose. Yeah, I guess we are all together. Good. Let's continue. So now understanding the binomial distribution. Okay. So it's like this will be a repetition of what we've already discussed. Okay. But I can just read through the notes so that we may see if we are missing any point. Okay. All right. So the binomial distribution is a common discrete distribution used in statistics as opposed to continuous distribution, such as normal distribution. So this is because the binomial distribution only counts two states, typically represented by 1 for success and 0 for failure, given a number of trials in the data. The binomial distribution thus represents the probability of x, that is probability of success in n trials, okay, given a success probability p for each trial. Okay, so basically that is probability of success is always denoted by what? By p. Okay, then meaning the probability of not success will be 1 minus what? Minus p. This will be the probability of not success. This is the probability of not success. This is the probability of what? Success. Okay. Also, for those who learned that is a survival analysis, you can remember that 1 minus p was equal to what? Q. Because p plus q was 1. In this case, what it means is that probability of success plus probability of not success or fail should give you 1. It's like the probability of death and the probability of survival. All those two should sum up to what? To 1. Okay, if you can remember, like we were using like PT, like we are saying that T is time in terms of years. Okay, so PT will be the probability of you living or surviving for the next T years. Okay, and also we had QT, which was probability of you dying after what? After T years. Okay, that was under survival analysis. Survival analysis. For those who maybe did statistics or actuarial science. Okay, all right, that was just an highlight. So we know that P plus Q is equals to 1. So P can also be plus into 1 minus P should give you what? 1. Okay, so 1 minus P should be equal to P minus what? Minus 1. Okay, yes, that is, this is the probability of not success, that is Q, is equals to, sorry, sorry, this is not correct. This conclusion is not correct. So we know that the probability of not success, okay, this is the probability of not success, will be equal to 1 minus probability of success. Okay, yes, basically this 1 minus P, it's always Q. Just note that is always Q. All right, good. Let's continue. So this is because the binomial distribution, yes, we've already said that. So binomial distribution summarizes the number of trials or observations when each trial has the same probability of attaining one particular value. The binomial distribution determines the probability of observing a specified number of successful outcomes in a specific number of trials. Okay, so the binomial distribution is often used in what? In social science statistics as a building block for models of that is for dichotomous outcome variable. Okay, like whether a republic can or a Democrat will what? Will win the upcoming election, or maybe even it's in Kenya. If it's either Raila or maybe Ruto will win. Okay, so I guess that is something we could have maybe we could have asked ourselves. Okay, during that is the election period. Okay, all right. I guess we are good up to that point. So let's continue now with the analysis of what? Of binomial distribution. So basically this is the function for what? For binomial distribution. Okay. So binomial distribution, okay, of x given n times, that is the probability of uh, x successful trials given n trials will be equal to n combine x multiplied by p, which is probability of success raised to the number of successful trials multiplied by probability of not success raised to the number of what? Failures. Okay, or failed trials. Okay, remember these are successful trials and n is the total number of trials. So the number of non-successful trials will be n minus what? N minus x. Okay, so in this we can also say that n, that is n combined x, can be given by probability of success raised to the number of successful trials into 1 minus p, okay, multiply by number of successful trials minus what? That is number of total trials minus successful trials. Okay. So basically, n combine x, this is something we can calculate in Excel. Okay. And if we can't calculate in Excel, we usually have, that is a formula which simplifies this. So x combine x, that is n combine x, is the same as saying n factorial, okay, divide by, okay, x factorial into n minus what? N minus x factorial. I guess that's true. I guess that's true. Yes, that is true. That is n factorial divided by x factorial, okay, is equal to, that is multiplied by n minus what? N minus x factorial will give us now the combination. Okay, so in this case, we can say now our formula can also be rewritten as n factorial divided by x factorial into n minus x factorial, okay, multiply by, this is multiply by p raised to x, okay, multiply by 1, that is into 1 minus p raised to n minus what? N minus x. Okay, so this is the formula for binomial distribution. Okay, like for example, uh, let's assume n is what? N is 5. Okay, and what will be n factorial? So what factorial does, it's like you are that is decreasing, or it's like you are doing product, okay, of all numbers between 1 and 5, okay, in a step of 1, like we are decreasing the value by 1, then doing the what, up to 1, that is up to the smallest value, which is 1, okay, then multiplying all. Like for example, if we say 5 factorial, what it means, it will be 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, if we say 3 factorial, we are saying that it is 3 multiplied by 2 multiplied by 1. If we say 4 factorial, we are saying that it is 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, so basically that's what factorial means. Okay, so meaning, if maybe we are given the value of n, okay, if we are given the value of, that is the number of trials and the number of successful trials, okay, and the probability, then it will be what, easy for us to calculate this. Why? Because we know that, let's assume, that is n, we have 5 trials, okay, then out of the 5 trials, 3 trials were what? We are successful. Okay, like for example, when we are given the example of throwing maybe the ball through the basket. Okay, so if we draw this, that is the ball through the, that is successfully through the basket, then we term that as what? As one success. Okay, so in this case, if, okay, we are assuming that we have 5 trials, then out of the 5 trials, 3 trials was where that is where success. And definitely we can now say that the probability of a throw, that is of making a throw through the basket and not making a throw through the basket, is what? Is 0.5, because that is the probability of the two possible outcomes should be what? Should be the same. So in that case, now computing the probability, okay, the probability of maybe 3 out of 5 events occurring will be, this is the probability or the binomial probability that, okay, that 3 out of the 5 trials will be what? Will be a success. Then it will be equal to, that is 5 factorial. And we said 5 factorial is like 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by what? By 1. Then divide by x factorial. Our x factorial is 3, so it will be 3 factorial, which will be 3 multiplied by 2 multiplied by 1. Okay, then we are multiplying that with n minus x. So n minus x in our case will be what? Will be 2, which is 5 minus 3. It's 2, meaning it is 2 factorial. So in this case, we will have 2 multiplied by what? By 1. Then multiply by, okay, 0.5, which is our probability of success, raised to the number of what? Successes, which is raised to 3. Then multiplied by, okay, that is the probability of what? Not success will be 1 minus what? 0.5, which is will be 0.5 raised to n minus x. N minus x, we've seen it's what? It's 2. So raised to what? Raised to 2. So in this case, these will cancel and these will cancel. Okay, here will be left with 20. So 2 divided by 20, you'll get 10. So in this case, we'll get 10 multiplied by 0.5 raised to 3 multiplied by 0.5 raised to what? Raised to 2. Can maybe someone help us with this calculation? So basically I can say, yes, you can, so I can say it is 10 multiplied by 0.5 multiplied by 0.5, okay, multiplied by 0.5, okay, multiplied by, of course, 0.5 again, multiplied by 0.5. Okay, so in this case, this 0 will cancel with this, so meaning it is 5 multiplied by this will be 5 multiplied by, this has cancelled out, 1 2 3 4 will be 0.5 raised to what? Raised to 4. And this will be, can someone compute this? If you have a calculator, okay, let me open also mine. 0.5 multiplied by 0.5 multiplied by 0.5 multiplied by 0.5. So in this case, I'm getting 5 multiplied by 0.0625. So it will be now multiplied by 5, which will be 0.3125. So this basically will be the probability, okay, of having 3, okay, a successful outcome, give that is of having 3 successful trials, okay, given n number or given 5 number, that is 5 trials. All right, any question? Was that understood? Was that well understood? By show of thumbs. Steve, that was well understood. Uh, okay, the others. Oh, nice. Can see that was clear. So basically, that's what that is binomial distribution entails. Okay, so maybe to go through these notes, we are saying that the expected value or the mean of a binomial distribution is calculated by multiplying the number of trials by the probability of success. Okay, which is n multiplied by what? By p. Basically, this is the mean. So the mean, we usually say the mean of binomial distribution is n multiplied by what? X. That is the total number of trials multiplied by the probability of what? Success. Okay. You'll also see that that is for the probability of all the variance will be n multiplied by x multiply sorry, n multiplied by p multiplied by q. So we say that n that is into 1 minus p, okay, multiplied by what? By p. Okay, so in this case we can say it is n minus n p, okay, multiplied by what? By p. Okay, so basically it will be, it's like we are saying that is np multiplied by 1 minus what? P, or npq. All right, okay, so that's the mean. That is np is the variance, npq is the sorry, np is the mean, and the npq is the variance. Okay, yes, so I have already uh, illustrated that. All right, let's continue. So that is the mean of binomial distribution is what? It is NP. All right. Then the variance of the binomial distribution is NP multiplied by what? By Q. And we know that is Q, it's what? Q, it's 1 minus P. Okay, which we had that is illustrated here. Okay, all right. So when p is 0.5, then the distribution is symmetric around the mean. When p is greater than 0.5, then the distribution is skewed to the what? To the left. When the p is less than 0, then the distribution is skewed to the right. We are saying that the binomial distribution is the sum of series of multiple independent and identically distributed Bernoulli's trials. Okay, how does it happen? So you will find that now for Bernoulli, that is for Bernoulli distribution, when binomial distribution, that is n is equal to 1, or when we do one trial or one binomial trial, then that will be referred as Bernoulli distribution. Okay, if n is greater than 1, or let's 2, then this becomes what? Binomial, that is binomial distribution. Okay, so we can say that a binomial distribution of one trial is what? Is Bernoulli trial or Bernoulli distributed. Okay, so we are saying that the binomial distribution is the sum of that is a series of multiple independent and identically distributed Bernoulli's trial. In Bernoulli's trial, the experiment is said to be random and can only have two possible outcomes, either success or failure. Okay, for instance, flipping a coin is considered flipping a coin once is considered as Bernoulli trial. Each trial can only take one or two values, that is heads and tails. Each success has the same probability, that is the probability of flipping a head is 0.5, so probability of flipping a tail will also be 0.5. And the results of one trio do not influence the results of another. So basically what we are saying that the Bernoulli distribution is a special case of binomial distribution where the number of trials n is equals to 1. Okay. Yes. Then maybe under takeaways, basically takeaways are what we discussed. Like binomial distribution is a probability distribution that summarizes the likelihood that a value will take one or two independent values and a given set of assumptions. Okay. And then we talked about the underlying assumptions to be, that is, we expect only one outcome for each trial. Okay. Then and each trial has the same probability of success, and that each trial is mutually exclusive, or it is independent of what, of one another. We are also saying that the binomial distribution is a common discrete distribution used in statistics as opposed to continuous distribution such as normal distribution. Any question about that is binomial distribution? So maybe for Poisson distribution, of course I will share these notes after the class, so you can go through the Poisson distribution. Okay, then on Monday we will have a discussion on Poisson distribution and then start the practicals right away. Okay, so on Monday we'll do the Poisson distribution, the theory, and then do that is the practicals. Okay, so the practicals for these, they won't take much time because we'll just be trying to, we'll get some data, then out of the data we'll calculate maybe some probability mass functions. Okay, so that we may see maybe the probability of different maybe trials happening. Okay, all right. Any question as I that is why